at 6:30 right now. So once again, welcome all of you to Vedic Maths Part 3. This is session number 5, and in this session we will do some test preparation. So how we are going to deal with worded problems using Vedic mathematics, that's what we will be doing in this particular session. So once again, welcome you to the 5th session. We will just keep 2 or 3 minutes for buffer so that the students can uh, have time to log in so that they won't miss any material. In the meantime, those who have joined the chat, you may just go to the YouTube settings and adjust the video resolution accordingly. So let me just go on to the chat to see the students who have joined. All right. So I hope I'm audible, and also the slides are visible on your screen as well. So just give a feedback if you can see the slides properly as well as you can hear my voice. Okay, I think students are just logging in, so we can wait 2 or 3 minutes for the students to come in to the room. So once again, I will just give an overview of today's session. So today what we will look into is mainly test preparation. So we will see some word problems that has that are problems related to real world, and we will apply Vedic mathematics sutras in order to simplify the problem, and also that will help in doing the problem using mental arithmetic. So this will be useful for any competitive examinations that the student is going to take, and the approach will be using Vedic mathematics. So let me have a look into the chat. All right, I think students are still joining in. We'll just wait for 2 more minutes. In the meantime, those who have some doubts from the previous session can ask those. Also, we had posted a project in the last class, and few students have actually submitted it, and there were 2 problems, and what we'll be doing is we'll be discussing those problems also in the test prep session that is going to happen today and tomorrow. All right. So to give an overview of what we have done previously, we will see this Sutra Tree. So the Sutra Tree we introduced in the last session comprises of the first 8 sutras that form the Vedic mathematics. Now we introduced only the English names. It is not mandatory to know the Sanskrit names. And the first sutra that we introduced is by one more than the one before. So this is the fundamental sutra, for counting numbers, or what we call it as natural numbers. So the natural number set is 1, 2, 3, etc., going up to infinity. And the sutra, by one more than the one before, is just a method that utilizes the generalization of this counting numbers. And a typical example where it is used is the 10-point circle. And the 10-point circle is a very useful tool in order to do addition. The second sutra that we introduced as a part of Vedic mathematics is all from 9 and the last from 10. And what the sutra does is commonly called as the Nikhilam method. So I'll write it here. It's called as the Nikhilam method. Hope everyone is able to see that. Okay, I think the ink is not visible with this background, so I'll just change the ink. So this is commonly known as the Nikhilam method. That is, you subtract every digit except the unit digit from 9, and the units place digit you subtract from 10. This is connected to the 9-point circle, which we introduced as a part in the part 2 of this course. The third method, this is the most widely used sutra across Vedic mathematics. It is called as vertically and crosswise. It has got tremendous applications in doing multiplication problems, and also as we see division problems, this sutra is utilized widely. The fourth sutra is what is called as transpose and apply, and it is commonly known by the vinculum argument or vinculum method. So vinculum method is using what is known as bar numbers. So negative numbers are written as bar numbers in this particular approach, and this will tremendously decrease the complexity while you do both addition as well as multiplication. So any problem can be transformed into an addition or multiplication problem using this transpose and apply method. The remaining 4 sutras, we have not covered much examples here in this course, but still for the sake of completion we'll state it here. If the samuchaya is the same, it is 0. So the meaning of samuchaya was told to be the ratio. So if there are two quantities which are in the same ratio, then their difference is 0. That is the meaning of the sutra. A similarly sounding sutra is if one is in the ratio, the other is 0. So these two fall under the same category, only with minor applications, minor variations depending on the area of where it is applied. The 7th sutra is what is known as by addition and subtraction. So this sutra actually tries to map a problem into a problem that where the base is utilized or the base number is utilized, and the common bases that are known to us are 10, 20, 30, etc., all the multiples of 10. So by using the sutra called by addition and by subtraction, we mean that we round off the problem to the bases of 10, 20, 30, etc. The last sutra here is known as by the completion or non-completion. So this particular sutra by the completion or non-completion is a generalized version of Sutra number 7, and it helps into doing mental arithmetic very quickly using the same approach of base addition or base multiplication. So with this brief introduction, we are now ready to see two applications of the sutra where division is the operation. So in the last session, we introduced how to divide a number by 9. So just for the sake of revision, let's consider 57 divided by 9. So the approach that we did is write 9 here and 57 here. So 9 is very close to the base 10, and 9 plus 1 is 10. So the method actually enables us to do this division problem quickly, and the first step is to bring this first digit, which is the tens place digit, as it is to the answer, and then we bifurcate the number 57 into two parts. Because the base is 10, one digit is there in the remainder part, so 7 will be the digit place which is going to decide the remainder. Now we multiply 1 with 5 and write the answer here on top of the line, and this will give a remainder of 7 plus 5, which is 12. Now a student of mathematics will question whether the remainder while dividing 9 can exceed 9. So this problem with the answer 5 remainder 12 is not in the simplified notation. So in order to simplify this, what we should do is we should reduce 9 from the remainder and add 1 to the quotient. So the final answer would be 6 remainder 3, because upon subtracting 9 from 12 we get the answer as 3, and the 9 that we subtracted adds 1 more to the quotient. So this is the logic behind solving 57 divided by 9. Alright, so I'll just go 1 minute to the chat and see who all are there in the chat box. So I can see Charan, Deep and Shashi. Hello Charan, and hello Shashi. Good evening. So are you able to understand the concept of division which is carried out from the previous class? So this was just a revision problem. Hi Adityan, I have seen Adityan's assignment. I think only Adityan and somebody else has only submitted it, I guess. Yeah, good evening Adityan. Alright, so everybody, did you understand the logic of doing 57 divided by 9? So this is a direct application of vertically and crosswise while we do for division. In fact, this is called as the inverse of vertically and crosswise. Yeah, good evening Mani. Nice to see you on the chat. So how many of you have understood? So if you have understood, give a thumbs up in the chat box so that we can go to the next problem. So today's session is mainly meant for test preparation. So we will be looking some word problems. So before we go into that, we plan to do some revision so that the students can understand. Yeah, so Mani is asking how to do the crowning gem method. So this is a part of the crowning gem method. So crowning gem method is most generalized version. So if possible in tomorrow's class, I will try to introduce the crowning gem method. If you learn that method, you can do possibly all kind of divisions using that method. All right, so let's go to the next problem. So before that, we have the visualization of this coming. So whatever is written in the pen is now visualized. So the final answer is 6R3. All right, so let's look for the next problem. So this is a problem for all of you to solve. So what is 96 divided by 9? So that is the question. And the first hint is given to you. What is 96 divided by 9? So first of all, you have to write 9 plus 1 is 10. So you can write 1 is the extra factor that has to be considered. So you bring this 9 as it is below. So this can be brought as it is. And you divide meaning you separate the two digits of 96 as 9 and 6. So 6 is going to contribute towards the remainder. So you add 9 plus 6, the answer is 15. So 9 or 15 is going to be the answer. But an intelligent student should notice that the 15 here is greater than 9. So what you have to do is you have to subtract 9 from this, and what remains is the remainder. So 15 minus 9 is 6. So since you have subtracted 9 from it, you have to add one more to 9 in the quotient. So the answer is going to be 10 or 6. So that is what you get here. That's why the answer is 10 or 6. So let's do some quick exercise problems. So practice problems. What is, let's do this last one over here. What is 707 divided by 9? So all of you can start doing this in the notebook. Meanwhile, I'll solve the first problem and we can verify for each other. Okay, so I think this. So I'll have to figure some space here. So everyone can solve for C part. Meanwhile, we'll be doing with the other answers as well. All right. So I can see one answer has come up in the chat box. Let's wait for maybe one more answer to be typed in the chat box so that we can verify this one. So as always, we start by writing this problem like this: 707. 9 plus 1 is giving 10. So you can draw like this. 7 is brought as it is down. Do 1 multiplied by 7, it is 7. You add to this. So 7 plus 0 is giving you 7 again. Now there will be a separation over here to compute the remainder. So that is going to be the remainder. You multiply here, 7 times 1 is 7. So remainder is 14. But 14 is a number that is larger than 9. So you can write this answer to be 78, remainder 5. All right. So I can see some of you have written Azim has understood, it seems. The answer given by money is 9 or 8. So probably 9 or 8. Is it the answer for this A part? So that's not clear. So I guess 9 times 9 is 81, plus 7 will give you 88. So this answer seems to be right. For the B part, 8 times 9 is 72, plus 5, the remainder will give you 77. So that answer also seems to be right. Now for 78 multiplied by 9, you can do 80 multiplied by 9, which is 720. 720 minus 2 times 9, that is 702. 702 plus 5 is 707. So this answer is also verified to be correct. Alright. Now we'll go to a different set of examples where you want to divide by 8. So in the previous slide we were seeing only examples of division by 9. In this particular case we are going to see examples where you divide by 8. So the first problem here is 1121 divided by 8. So the problem, I'll just write it here, 1121 divided by 8 is the problem. So in this problem, we first figure out how much should be added to 8 to get 10. So 8 plus 2 is 10. So the first step, as before, you can bring the number 1 as it is down. Then you multiply 2 with 1. 2 with 1, when you multiply, the answer is going to be 2. You write it here above the line. Add these two. 1 plus 2 is 3. Now you multiply 3, this digit 3 with 2, the answer is going to be 6. The answer 6 is then added to 2 to give 8. Now since 8 plus 2 is 10, you have to separate or bifurcate one digit here like this. Then you do the remaining problem. 8 multiplied by 2 is 16. So 16 plus 1, you will get the remainder to be 17. Now the number 17 can be written as 8 multiplied by 2 plus 1. So this answer is same as, so there are two 8s, 2 times 8 appears in 17. So the remainder becomes 1 and the quotient has to be added. So the quotient has to be added with 2. So the final answer would be 140 remainder 1. Alright, so is this understood? It is slightly complex, but as we do more and more examples, you will understand it. So let's take one more example. This problem is asking us to do 100 divided by 8, which is a very common problem that appears. You have, say, 8 pens in a pen set, and the pen set costs around 100. So you want to find what is the cost of one pen. So let's see how we compute it. Let's use a different color because otherwise it's confusing, it seems. So 8 plus 2 is going to give you 10. Now what you can do here is you can bring the number 1 as it is down, multiply 1 with 2, the answer is 2. So you will get 1 followed by 2 here. So this is the step that we did. This we brought down as it is. Now the next step, you should put a separation here. 2 multiplied by 2, 2 multiplied by 2, we know it is 4. So you have to add 4 here. So that will be your remainder, which is 4. So what it means is that the pen would cost 12 rupees and 4 by 8 fraction of a rupee, or in other words, this is 12 and a half rupee. So if you have a pen set that has 8 pens in it, a single pen would cost 12 and a half. So everybody know the answer, but what we have seen is that it can be computed very easily using the method that we just introduced, which is inverse of vertically and crosswise. Another name for this method is also called as a crowning gem. So this method is also known as the crowning gem, but we need to introduce this crowning gem in a little bit more detail, which we will do in tomorrow's class. Now this is an exercise for all of you. So you can take 1 minute and try to solve for this. What is 214 divided by 8? What is 214 divided by 8? So this is also a very direct question. You can apply the 3-step method. What is the 3-step method? In the first step, what you have to do is identify to what number should I add 8 so that I get the answer as 10. You will get the answer to be 2. 8 plus 2 is 10. Then bring the first digit from the right side as it is. The first digit is 2. You multiply 2 with 2. The answer is 4. You write it here. Now you bring the sum 1 plus 4, which is 5. So 5 is brought down as it is. The last number you separate it, that will contribute towards the remainder. So you multiply 5 multiplied by 2 is 10, and you add it. 4 plus 10 is giving a remainder of 14. So the answer that we got is 25 or 14, but again a student who is keenly observing will find there is some more simplification that we can do, because when you divide a number by 8, the remainder should not exceed 8. So in this case the remainder is 14, so we have to reduce that remainder below 8. So in order to do this, we can write 14 equal to 8 multiplied by 1 plus 6. So the new remainder is going to be 6, and to accommodate this 8 you have to add 1 to the quotient. So the final answer here is going to be 26 remainder 6. So this is the final answer for the problem. Yes, so I think Mani has given the correct answer, 26 remainder 6. So it's a remainder 6, it's not 4. Alright. So hope everyone is on the same page. Hope you have understood till this much. Yeah, so TG Thunderstorm is asking something in the chat. So I'll take some questions before we proceed into the test prep questions. Okay. So yeah, so TG Thunderstorm, I don't know, I don't recall. Bhuvan, is it Bhuvan? Alright, I remember you, Bhuvan. Yeah. So Bhuvan, do you understand what is meant by this division in the Vedic method? Yes, I recall your name, Bhuvan. Alright, so I hope this is understood. If you have any more doubts regarding this, I am happy to take it right now. So for all students in the chat, for all those students who are attending the class, if you have any doubts regarding the division using the Vedic method, please type that in the chat box. Alright. So I think we can continue, and at the end of the session also I'll give some time for you to ask questions. So let us go to the first question that was asked in as a part of worksheet 1. So this is exercise question 1. So the question is, a tortoise takes 121 steps to walk a distance of 10 feet. So there is a 10 feet long path, long road, and to reach the end of the road, the tortoise takes 121 steps. Then how many steps does the tortoise walk to complete a marathon? Marathon meaning a long running race, which is 3020 feet. So the first point to note here is that we have used this unit called feet. So generally distance in road etc. we will measure it using the kilometers as the unit. Whereas if you see your home, your room where you are sitting, all these are measured in feet usually, because it is easier to correlate what is meant by feet. So the general relationship all of you can remember is 12 inches is equal to 1 feet. So this is the general conversion that we can use. So this is a very direct problem. It uses the Samuchaya method that was introduced in the first slide. So if the ratios are the same, then their difference should be 0. So what is remaining the same here is the velocity with which the tortoise is moving. By velocity we mean speed. The speed with which the tortoise is moving is the same. Okay. So 121 corresponds to 10 feet. So we want to find this quantity, how many steps are there for 3020 feet, which is nothing but 302 into 10 feet. So every 10 feet the tortoise is moving 121 steps. So the question is how we will find 121 multiplied by 302 using the vertically and crosswise method. Alright. So I can see Harshit has commented in the chat box. Harshit, is it a question? Do you have a question? Okay. I can see Bhuvan has given an answer, but the answer seems to be written differently. Just check once more. There is no decimal in the answer, I guess. Okay, so there won't be any decimal in the answer. So others who are just listening it, you can try how to do 121 multiplied by 302 without a calculator. Please do without a calculator. So we will invoke the vertically and crosswise. Everybody remembers the vertically and crosswise? VC, VC and CV. This is the method. For 3-digit multiplication, we know the method is vertical, crosswise, vertical and crosswise, crosswise, and then finally vertical. So 121 multiplied by 302. So the first vertical step is going to be 1 multiplied by 3. The answer is 3. We'll put a colon to separate the answers. The next is crosswise. 1 multiplied by 0, 3 multiplied by 2, which is 6. Colon. Next is both vertical and crosswise. So the crosswise is 2 plus 3, which is 5. Now 5 plus 2 multiplied by 0. 2 multiplied by 0 is 0. So the answer is 5 itself. Next is the crosswise step. In the crosswise step, you have to do 2 multiplied by 2, which is 4. 4 plus 1 multiplied by 0 is 0. So answer is 4. And the last step is just 1 multiplied by 2, the vertical step, which is 2. So the final answer is 36542. So this is the number of steps taken by the tortoise to reach the end of the marathon. Alright, so Bhuvan has given the answer right now. Alright. So I think earlier Bhuvan had made a different assumption, it seems. Okay, fine. So everybody please comment in the chat box if you have understood it or not. If you have understood, kindly give a thumbs up. All right. All right, so we'll go to the next problem then. The second problem is also a part of the worksheet that we introduced. And the question reads, if the Christmas day, which is December 25, which is approaching very soon. Now, if the Christmas day in the year 2022 is a Sunday, then the Republic Day of India in the year 2023 will be which day? So that is a question. So we have to see what is the approach that we can do in order to solve this. So everybody has seen a calendar, right? So in a calendar you will have days, 7 days of a week, and what you will be having is month. So December, there is a December month here, 2022. So the Christmas happens to be a Sunday. So let's write like this. Let's begin the week by Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So 25 is somewhere here below a Sunday. Now if you take January of 2023, you have to say when is the date 26th. So 26th is the Republic Day. So which day does it fall under? So this uses both the sutra by addition and subtraction, and also the sutra by completion and non-completion. So you know December is a month which has 31 days. So if you add 7 to 25, it will be 32. 25 plus 7, the next Sunday is going to be 1st January. So if I write like this, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, 1st January of 2023 is going to be a Sunday. Now from this you can easily find out many things. If I keep on adding 7, I will get the dates which fall under Sunday. So 1 plus 7 is 8, 8th is a Sunday. 8 plus 7, 15th is a Sunday. Then 15 plus 7 is 22. 22 is also a Sunday. So after 22, 23 is a Monday, 24 is Tuesday, 25 is a Wednesday, and 26 is a Thursday. So the correct answer here would be Thursday, isn't it? So let's take this one. So Thursday is going to be the Republic Day of India in the year 2023. Okay. Alright, so Bhuvan has checked the calendar and verified for all of us. So it is in fact correct. It is a Thursday. So this is how you can apply Vedic mathematics sutras very easily. So this is a very direct method that we have tried here. What we did is a sutra which is called as by completion and non-completion. So we have used the given information, which is 25th of December is a Sunday, and kept on adding 7 because that completes a week. And finally, when we reach the point of completion, we are using non-completion to get the date that we are asked for. So this is the method known as by completion and non-completion. So I hope it is understood to everyone. So if it is understood, let's move on to the next problem. So exercise number 3. So this is a question that everyone can read for a few seconds. So you can take around 30 seconds or 45 seconds to read the question. In the meanwhile, I will talk to you about the ages, the problem of ages. So this is what is called as a word problem, and this is commonly appearing in many competitive examinations. So we are going to examine how we can approach this problem using the Vedic sutras that we learned. So the question reads, the present age of Raju is 15 and the age of Radha is 8. After how many years would the total of their ages be equal to 35? So this is the question. So the present age is given, and what is asked is how many years later would the sum of the ages become 35? So in these problems, we have to depend on algebraic expressions. So I hope everyone recalls what is meant by algebraic expression. So algebraic expression is an expression that is written with an alphabet x, which is an unknown quantity or a variable. So this x can be either unknown or it could be a variable quantity. We don't know what is the value of x. So by reading the question, we understand that the present age of Raju, so Raju is there, his present age, let's write age present, this is equal to 15. Similarly, there is Radha, whose age at present is 8. Now, what will be their ages after some years? X. So after X years, what will be their age? That's what we want to find out. So let's take this one. So age in the future, let's write age in the future. So age in the future for Raju, it is going to be 15 plus X. So hope everyone can see this and it's not being hidden. So the age of Raju after X number of years is 15 plus X. And the age of Radha after X number of years is 8 plus X. Now what is given to us is the sum of the ages, which is 15 plus X. This is an algebraic expression because it has the unknown alphabet X. So the sum of the ages is coming from the total, So total of this is going to be 35. Now from this we can add the two x's. There is x plus x. So x plus x is 2x. There is 8 plus 15. What is 8 plus 15? 8 plus 15 is 23. So 23 plus 2x equal to 35. This is what we get. So from this we can simplify and get 2 times x is equal to 35 minus 23. 35 minus 23 is nothing but 12. What this implies is that x is half of 12. So from this expression, what I understand is that the value of x, so after how many years, this is what the question is, this how many years we have taken as x. So from this expression, I understand that x should be half of 12 or it should be 6. Alright, so this is a very typical question that we encounter in any competitive examination. So in our present case, we have applied the sutra which is required for halving the quantities, and this comes under by the completion and non-completion once again. So the sutra that we applied here is by the completion and non-completion. And the second sutra that we applied here is by addition and subtraction. So we have added 12 here so that 23 plus 12 becomes 35. So that method is called as by addition and subtraction. So these are the two sutras that we have applied to solve this current problem. Alright, so hope you have understood. So we'll just move on to the final problem for today's session. So this is a word problem again. So it's very directly asked. There is only one sentence to this word problem. So again we are dealing with this aspect of algebraic addition or algebraic expression. So by now everyone should be familiar with what algebraic expressions are. So algebraic expressions have this alphabets x which is either unknown, it is either unknown, or we called it in the previous slide, it can be a variable also. It can be a variable in some instance. So now we have to find what is the value of x for which this is read as 25%. 25%. So what is the value of x for which 25% of x is equal to 50% of 300? So in other words, 25% can be written as 25 by 100, which is equal to 1/4. And 50% can be written as 50 divided by 100, which is equal to 1/2. So what is being asked is, for what value of x, what is the value of x for which 1/4, 1/4 part of x. Imagine x is a cake. Imagine x is a cake. So 1/4 part of the cake is being cut, and the total weight or total cost of the cake is 300. So the 1/4 part of the cake is having, say, only half the price. So this might be a possible question. So there is a large cake which when cut to 1/4 pieces or 4 pieces, its cost is only half of the total cost. Then what is the cost of the true cake? So this can be easily found by cross multiplication, right? So you can take 4 to the other side, you can bring 2 to the other side. So you get 2x equal to 4 multiplied by 300, or x is just equal to 2 multiplied by 300. So this is just the doubling operation that we have done. So the answer is 600. So all these percentage problems can be easily approached using the expression, using algebraic expression, and it is also possible to use the doubling and halving operation in order to simplify the answer quickly. So with that, we come to the end of today's session, and what we'll do next is we'll take some questions if the students have any. So I request any student who has any questions to kindly type that in the chat box so that we can clear them as soon as possible. All right. So in the meantime, let me just see if this is so this is part on. All right. So I could see the assignments being submitted by Aditya and one more student. So I'll be discussing the worksheet number 2 only tomorrow. So until then, you can submit the answers to assignment number 2. It is available in the chat box or the description box of the previous lecture. Okay, so I think there are no more questions I can see in the chat box. So I think we can part our ways for today and join tomorrow at 6:30. So tomorrow is going to be the final lecture. We will do test prep number 2, where we'll include questions from different branches of mathematics and see how we can apply the Vedic sutras there. And I'll also give you the details about the crowning gem, which is one of the principal Vedic mathematics sutras. All right. So thank you once again and namaste. Thank you for joining.